Hello students, welcome to my YouTube channel Data Guru Akash, and in this video we are going to talk about
normalization. So we do the normalization of input features only, first thing, right? You do the normalization of input features. And why do we do this actually? See, if we have, let's say, two input feature, let's say x1, we have x2. Input feature is nothing but, let's say, age, right? Now, what would be the range of age for human? What would be the probable range of age for humans? 0 to 100, maybe, yeah, correct, like it could be 0 to 110, sometimes maybe very rarely 120, but not more than that. I guess the range would be somewhere, let's take it 0 to 100, right? 100 in years actually. Okay, now let's say there is income. This particular feature is income, right? Income can be what? Income can be very large, right? So you see there are two values in this particular column, in this particular feature, and one having very less values, one having very large values. So the model or the program will not be able to know like what does age means, what does income means, right? It is just treating them as a particular feature. It's a feature one, feature two, simple. It does not know what is age and what is income. It does not know any correlation with that. So what do? We try to make all the values in every column like in the same range, right? For example, you have 0 to 100, and let's, for example, 0 to 1 crore, right? This income is 0 to 1 crore. So you see this particular thing is very high, right? The range for this particular thing is very high. So what can be done in this case? You can normalize it, right? Normalization is done. So in normalization, you preserve the variance, you preserve the data integrity. You maintain the data integrity, so you preserve the variance. Variance of the data. So variance is the most important thing in the data that you preserve, and actually you do not you just change the range of the values, right? The whole effect is the same. Now I'll give you one example. There is something called there are two ways to do the normalization. First one is the min max normalization. Min max normalization. Now what is min max normalization? Min max normalization is nothing but there is a formula for it, right? So let's say you have some values. Let's say I have values in the range of 0 to 10. Let's say I have 0, 3, 5, 10, right? 8, 6, like this. Let's say these are the values that I have. And if I'm trying to normalize this particular column, if I'm normalizing this column, I will not use any other column in this. Okay. Now min-max normalization changes the range of the data from 0 to 1. Now how do you do? So there is a formula like x dash is equals to the corresponding x and minus x of min divided by x of max minus x of min. So if you put this particular thing in this formula, right? So what will happen? Let's say you want to change the range of this 0 scaled. So this is original. Now I want to be scaled. So what will be the scaled value of this 0? So scaled x scaled will be, so this particular 0 minus, what is the minimum value in this? That is 0 divided by x max, that is 10 minus 0. So it will be 0. So x scaled for this 0 will be 0. Similarly, if you do it for 3, so 3 minus 0, that is x minimum will always be 0, and it will be 10 minus 0. So it will be how much? 0.3. So if you calculate for all this, you will get 0.5, it will be 1, it will be 0.8, it will be 0.6. So you see, it did not changes the variance, how the data is changing. It did not changes the variance. It just changed the value, the range from 0 to 1. Like, so if you use the same formula, no matter what data range you have, it will change them always to 0 and 1, right? This is one example I took because if you just see the distance between max and min value, that is nothing but 10. So if you just divide it by 10 in whole values, you'll just get that. But if you do not have, let's remove these values here. Let's remove this here. Now, if you do the same, so the minimum value you see is 3 now. you always have to understand the minimum value will go to 0. The minimum value in the scale will go to 0. The maximum value in the scale will go to 1. And all the other values in between will be scaled accordingly into this method of min-max scaler. So you see, if there is no 0, right? So what will be the x-min? X-min will be 3. So for if you are going to scale 3, it will be 3 minus 3 and 10 minus 3. So it will be 0 divided by 7 and it will be 0, right? And if you are scaling this 10, so it will be 10 minus 3 divided by 10 minus 3. So if you see, that will be 7 by 7, that is 1, right? So it will be 1. And everything in between will be scaled accordingly, right? For example, 5 or you check 6, let's say, right? So 6 would be the middle value, I guess, if I'm not wrong. So middle value, you will see that will always go to the 0.5. Let's see. So 6 minus 3 divided by, no, it's not 6.5 if we do, right? 6.5 minus 3 divided by 10 minus 6.5. So what will be coming over here? It will be 3 here, right? Not 6.5. So it will be 3.5 divided by 7. So you see what will it be? It will be 2. It will be 0.5, right? So the exact middle value will be 0.5. So you are seeing this, right? So if you know a little bit of statistics, you will be simply able to understand what is happening here. So the middle value will go to the 0.5, the lowest value will go to 0, the maximum value will go to 1, and everything in between will be scaled accordingly. Okay, so that's what the main thing about this min-max normalization. There is another thing that is the standard scaler. You can simply go and find the formula for this as well. And it does the same thing. It does not changes the range from 0 to 1. Basically, the scale of this is not fixed, right? It depends on the variance of the data. It has a different formula, but also it does the same thing. It preserves the variance. It just scale the values in a different range. So if you have it, if your data has more variance, so maybe the scaled value will have more variance as well. It will not scale the data to 0 to 1. Remember that it will have different values. So I will just implement it using the code and I'll show you what will be the value of for different. It depends on the data actually that you're taking as an input, right? There is also a formula for this. If you want to simply go through, you can simply search on Google and find the formula for standard scaler and try to implement the same thing for this as well, right? You will see that there will be different value for this. So that's the main idea. The main idea is you have to change the values of all the thing in the same range. If you, let's say, if you just make whole thing by multiplied by 100, you see the values will still be the same. The value that you will get, the scaled value will be still the same. So that's why the range factor will be, factored out. The range thing will be factored out after normalization. So the normalization is very, very important. Now, why do I say why do normalization is important? Because if there are two features, right, so they should be comparing with each other with the same range of values. If the range of values are different, so that will not be a fair chance to participate in the importance of the feature. See, this is the same region, right? You see in boxing there are something called groups, right? Group. So there will be groups of kgs, right? So let's say 50 to 60 kg group, right? So all the people with this particular weight, they will be fighting to each other. Anyone having 90 kg cannot find this because his weight itself is advantage for him. So we cannot give this advantage to this particular guy, right? That's why we can simply what do? We just have different groups of fighting, different weight groups for fighting. And one group of fighter cannot fight to the other group because higher weight is always an advantage, right? That sums up why do we do the normalization. That's the main reason. Like maybe in this case, higher value, having higher range of values, maybe giving some edge to this, right? Or lower value might be giving some edge to this. We cannot clearly say that. Right. So that's the reason we normalize and give all the feature equal chance in participating the importance of the data. If you have only one input feature, do you need to normalize that or not? And I told you that you only need to normalize the input features only. And you will not normalize it because there is no one to compare, right? There is only output, and if you have one feature, you do not need to normalize it. One more thing, before going to this, let's say you have normalized, you have done all the things. Let's say I have this particular table. We have x1, we have x2, we have x3, we have x4. Let's say 4 features and one particular output, y, right? Y. So you see, this is the output. So what you have to do, you have to divide these all input in a different set and output in a different set, right? So this will be divided into y. This output will be divided divided, and that will be called y. The input will be divided and that will be called x. So that's why I have given x1, x2, x3, x4 initially itself. Right? You can there would be any name here, like based on the data, there will be column names here, right? So we have x, we have y, we have the corresponding x, we have corresponding y. What will happen over here is you have to divide them. You have to partition the input and output data. So x will be input to the model, y will be output. In the total data, it will be combined together. The label output will be combined together, right? While before training, you have to separate them. You'll have to pass them separately, okay? All right. So these are the things that this is something you have to do. And apart from this, see, you are training your model, right? So like, let's say some student is learning, and after learning, they are examined, right? They are examined whether they have learned correctly or not, right? For example, you are telling a kid to recognize apple and orange. If you take the previous example, so you at the end will ask him to understand how much did the kid learn, right? So what you have to do, you will just show him apple, you will ask him what is it, you will show him the banana, you will ask him what is it. So you will be trying to analyze how much correct answer is he giving, right? So then you will be able to understand if he's a fast learner or if he's a slow learner, right? If you have if he takes a lot of time, if he takes a lot of data samples, that means he is a slow learner. Or if he takes less time, then he's a fast learner. The same thing we do in here. So we know that we only have the limited data, right? We do not just can generate the same data. We split the same data for training and testing. Okay. So we have the same data. So we will divide the same data into for training and for some data for testing. For testing purpose, you will require some data as well. And you are going to get the data from the same data set that you have as an input, right? So you'll not use your whole data, right? For the training, you will keep some for testing as well. Why don't we do the testing with the same data that we trained, right? So let's understand this. Why do we do this? Why do we partition it, right? So for example, let's say there is a kid that you are teaching him some mathematics, right? You are teaching him, let's say, summation, how to sum two numbers. Let's say you are given some multiple example, let's say 1 plus 5, 3 plus 6, 8 plus 9, right? 2 plus 7, 5 plus 8. All these examples you have given in the classroom, right? 1 plus 4, 1 plus 2, 1 plus, let's say 7 plus 1, 8 plus 4, like this. So all these examples you have given in the class. And now when you have taught him the whole summation rule, and then you want to know whether he knows or not, then what happens? You ask him a question. You ask him that, tell me what is 1 plus 2. If he answers correctly, right, then will you be able to know that he has learned the rule or not? So the thing is, maybe he has not learned how to sum, but anyhow he has memorized all the answers that you had taught him. So let's say it would be 3, right? This was available in the training, in the learning, in the teaching. So it will be it may be the case that this kid has not learned how to sum two numbers, how to add two numbers together. He has just memorized the answer. So in order to verify that, you will not give those questions that you have given in the classroom, that you have taught in the classroom. You will ask that question, let's say 9 plus 3. You will ask that question that was never given in the classroom. Now if he is able to answer it correctly, let's say 9 plus 3, that will be 12. So if it is able to answer it correctly, then you can make sure that the kid has learned. The same thing happens over here, right? If you give the whole data for training and test it with the some of the data points from the training itself, you cannot know that whether the model has learned correctly or not. Sometimes, see, this is machine, right? They are very, very powerful at copying the understanding of the data. If you give the whole data, right, for training and then use some of the data for testing, making the predictions very, very correctly, and you cannot make sure that whether that has learned the model or not. That's the same reason, we split the data before training itself. So we will split the data into training and testing. That's all the difference. The most common portion is basically 70 and 30. So 70% of the data will be using for training, right? And 30% of the data will be using for testing. It can change as well. So as I, if you have, let's say, a huge number of data points, so you can also fix it as well, right? You can make it 60-40 as well. You can make it 80-20 as well. You can make it 65, 65-35 as well. You can make it 75-25 as well. It's up to you. So that's pretty much a fit. So these all things we required before creating any model. Okay, these all the things we required. So that is it for all the pre-processing and other stuff. Now I will go to the NumPy session.
Thank you so much for watching this video. If you liked it, do press the like button and subscribe the channel for future updates. Also hype the video so that it can reach more students and they can also get benefited from it. Thank you so much for watching this video. We'll see you again in the next one. Till then, bye bye and have a great day.